Hello, my name is Zeeshan Saeed and I am a PhD candidate at Politecnico di Torino. I am going to talk about my research in this video, which is related to identification of joint dynamics in mechanically assembled structures, particularly bladed discs found in aero engines or gas turbines. The bladed discs are rotating components which add or extract energy to or from the surrounding fluid. They are susceptible to premature failures if their vibration amplitudes go too high. Designers and researchers are always looking for methods to make them reliable. The weakest link in our understanding of the dynamics of bladed discs are joints. This is because they introduce uncertainty or relative motion at the contact interfaces. In order to understand it, let us take two simple substructures A and B. We know some output-input relationships on the coupling points and some internal points. We couple them mathematically and compare it with an actual measurement on their assembly. Are the two results comparable? Theoretically, yes. But practically, for real systems, no. Why? Because of some finite flexibility between the two interfaces that was not accounted for. And the joint flexibility is something we want to identify. So the first question is, how do we do that? We use the inverse approach to identify it. Consider assembly AB. Consider also the substructure A and B. So we decouple from the assembly the two substructures A and B whose flexibility is preceded by the negative signs. What do we get after the decoupling? The joint flexibility. This brings us to the second question. How do we measure interfaces if they are immeasurable, as in the case of a disc and a blade? For this problem, we use an expansion technique called system equivalent model mixing. We measure on the internal degrees of freedom of the blade and the disc and expand on the interface degrees of freedom. So we can identify the joint by using the expanded models in our research. But what about the measurement and modeling errors? Unfortunately, they do exist, and the identification methods are very sensitive to those errors. So one can only quantify those errors or reduce their effect. We also developed a method to find the most correlated measurements to reduce some modeling errors and improve the joint identification. And we are still continuing to reduce those errors. Thank you for listening and have a good day.